From the University of Nebraska-Lincoln's Center for Agricultural Profitability, this is Nebraska Farmcast. I'm Ryan Evans, and today I am glad to be joined by Dr. Cory Walters, Associate Professor in the Department of Agricultural Economics here at UNL. He recently co-authored an article analyzing how fuel efficiency in tractors has changed since the introduction of EPA emissions standards. Research was led by another co-author, Jaron Tukoski, a recent graduate of the Agricultural Economics Master's Program here at UNL. We'll be exploring the key findings from and getting Cory's perspectives on how emissions regulations have impacted tractor performance over time and why it's an important issue for farmers who are making equipment purchase decisions. Hey, Cory, thanks for joining me again.
Thank you for having me, Ryan. Glad to be here.
So just to start off, can you provide some background on what prompted this analysis of tractor fuel efficiency trends and why it's important?
Yeah, this thing first started off coming out of California with the California Air Resource Board, which as many people know is the place that starts a lot of regulation on pollution. That's a very contentious topic. They debated a lot there. I got to participate in a little bit of the debates, or at least listen to it. There's a lot of farmers there that speak up about that. And how we got involved here at the University of Nebraska is we have the Nebraska Tractor Test Lab. And it is the only tractor test lab in the United States or in North America where we can accurately measure how much fuel is being used at different engine loads.
And if you can walk us through the emissions standards timeline that's been established by the EPA, that would be great. And include how have the regulations progressed and gotten more stringent over the years, as I understand from the article.
Yeah, so this started back in the early 2000s. There was a lot of discussion about how do we move to cleaner environment, and so they implemented. They, as the EPA, along with stakeholders. Think of like the California Air Resource Board. They implemented tiers that came into effect over time, and they just continuously got better or stronger in their allowable emissions. What that did then was allowed manufacturers to understand how this was going to work and learn as they go through it. So the first one was tier 0, you could call it. That was pre any emission standards, and then we went to tier 1. And a few years later, we went to tier 2 and then tier 3 and tier 4 interim and then tier 4 final, which is where we're at today. And then there'll very likely be a tier 5 coming into the future. They already have that over in Europe. However, in that as well, the EPA allowed the tiers to start and stop at different times depending on the size of the motor. So you'd have to look at the size as well, but pretty much for the most part today in all major agricultural tractors, we're up at tier 4 final.
So what are some of the technologies that tractor manufacturers have adopted along the way to meet the emissions requirements, and how have they impacted engine performance?
Yeah, so start off with just some of the technology. So the first, through tier 1, tier 2. And then it started getting a little more gray in there, so I'll just stick to the first side. We'll just make that the simple side. So they just started changing simple things in the tractor where there was really no major changes that you could see like today. And today, when you go buy a new tractor, you're going to be purchasing an emission control system that's on the exhaust side. And the particular ones that we can see in the data are the diesel particulate filter, which just effectively, in an overview, pulls out particulate. That's one of the things that we need to get coming out of the exhaust. Then you have the diesel oxidation catalyst, and that essentially removes carbon monoxide, also particulate matter, and hydrocarbons. And then you have the selective catalyst reduction, or SCR, and that uses diesel exhaust fluid to essentially reduce the oxides of nitrogen. So those are the three you see typically today. And manufacturers had full movement on how they wanted to implement these things. They were not guided by the EPA. They just had to meet the emissions. And so over time, manufacturers adjusted how they did this. So on to the second part of your question there, how do these impact engine performance? you're talking about some of these, you're adding something into the system which can take more energy than to make it work. And that then can impact engine performance, particularly when what we're talking about here is just fuel efficiency. And depending on how each one of those works, some of them, they work differently, of course. They require more fuel during a regenerative process. So then that's where we would see the increase in fuel usage. And it's also been stated often by farmers that since the introduction of these things, their fuel efficiency has went way down as an observational approach to the problem.
Yeah, and your data showed that fuel efficiency dropped initially after Tier 1 and Tier 2 standards were introduced, but then it looked like it improved under later Tier 3 and Tier 4 standards. So why do you think you saw that pattern?
So, first, we had no idea what was going to come out of this thing, and we were surprised to hear that. But we did get some tips on this as we were learning about what was going on before we saw the results and talking to engineers that they were learning things. So what we have to keep in mind is that while we saw fuel efficiency go down, at the same time manufacturers were learning about how to meet these emission standards. And in that allowed them partially to improve their fuel efficiency at the same time. But the big one, that's the minor one. The big one, though, is at the same time when these things were introduced, these tiers, manufacturers are also improving other parts of the tractor's performance. They were adding in more turbos, intercoolers, aftercoolers, tolerances, fuel quality, electronic fuel injection, all these sort of things also helped improve fuel efficiency. At the same time, we were introducing these tiers. And one in particular, just the way that Nebraska tractor test data works, is transmissions. Transmissions have gotten a lot more efficient to transfer power from that motor down to that ground. And as we know in the Nebraska tractor test, we get to observe that. How much are they pulling through that motor? So yes, that's essentially the takeaway. Is at the same time there was a bunch of learning by manufacturers, and they were also improving other technologies in that system.
Great. And could you put it in context for like a field application like no-till planting? How has fuel efficiency changed from the pre-EPA standards to today?
Yeah, so we tried, instead of just taking the exact data from the Nebraska Tractor Test Lab, we tried to put it into the context of what farmers are actually do. And there is a model out there that we can use, and we know that every model has assumptions in it, but we're at least closer to reality than just being on an asphalt surface, measuring performance that way. And what we found is that today we are effectively better off with better fuel efficiency overall in things like no-till planting. We also looked at I think disking and a few other things. So your fuel efficiency is better today than it was back 25, 30 years ago.
What do you see as key takeaways from this research for farmers as they make these decisions about equipment purchases?
Yeah, we got a couple things there. First thing is, allow the manufacturers to learn when there's an introduction of a new regulation, because they are testing new systems and trying things, and they need to learn just as we the farmers need to learn as well. So when something new comes out, it's maybe not always the best time to buy it, or be aware that, well, there might be something in that system that we haven't quite seen yet because we haven't used it enough yet. But that shouldn't stop you from purchasing it. It could just delay it a little bit, or buy it knowing that you may have some warranty work with it. And manufacturers knew this. Oftentimes the warranties on those sides of the exhaust stuff was longer than the warranty on drivetrain and other components. Don't forget about all of the other changes happening simultaneously. It's easy to go pick on the emissions, but there's also a bunch of other things improving in that motor, in that tractor, that from the data we saw shows that fuel efficiency is actually getting better.
Great. And as manufacturers continue to work to meet future emissions goals, what potential challenges or opportunities do you think we might see ahead that impact that fuel efficiency in tractors?
So my understanding is, and I've not visited with a whole lot of manufacturers on this, but I've visited with people that have, is there's going to be more stringent regulations, and the one we did interestingly come across is manufacturers prefer to have just one set of regulations that they follow. So if they sell tractors, let's say in two regions, the United States and Europe, and let's say Europe adopts a Tier 5 motor, manufacturers will very likely put that Tier 5 in the tractors being sold here today. Is a little bit what we've heard of. So there may already be this stuff happening. The manufacturers nevertheless are learning about it, about what is a Tier 5. How do we work through it in their eyes, so that when it does happen here, it might be pretty seamless change, and we might not see anything of it. More recently, talking to farmers and stuff that have some more late model stuff, it seems to be that there's not as many problems happening as far as warranty work and things. But at the same time, the actual tractor, this is key. The actual tractor, we have to drive them differently than we did back before. Particularly with the particulate. You can't let it sit there and idle and let soot build up and then plug that particulate filter, if it has one, and because it's going to cause you an issue. You got to get those exhaust temperatures up high to burn that stuff out of there. And so it's things we have to learn as well, just like the manufacturers are learning.
Interesting. And what we've been talking about today is part of research presented in a article issued in October 2023 as part of the Department of Agricultural Economics Cornhusker Economics series. And we have reposted it on our CAP website as well at cap.unl.edu. Of course, look for that in the description to this podcast. Cory Walters is an associate professor in the Department of Agricultural Economics. And I want to thank you, Cory, very much for the info today.
Thank you, Ryan. Glad to be here.
Nebraska Farmcast is a production of the Center for Agricultural Profitability at the University of Nebraska-Lincoln. For the latest research-based information and education resources to manage your farm or ranch operation, visit our website at cap.unl.edu. That's cap.unl.edu.